Welcome back to UA Technical Solutions. Today we're diving into a common problem that many of us face: troubleshooting battery charges. Whether your charger isn't working at all or it's taking way too long to get your battery fully charged, we're here to help you diagnose and fix those issues. We'll walk you through all the steps to identify the problem. From checking the connections to testing all types of components, for example bridge rectifiers, diodes, MOSFETs, Schottky barrier diode, resistors, capacitors, Zener diode, transformer, ceramic capacitor and thyristors. So grab your tools, and let's get started on getting that charger back in action. Make sure to stick around for the full video so you can get a complete understanding of battery charger working principle and how you can find fault and fix it at home. Remove the PCB from the body and inspect for any burns and physical damages to the board might have happened, usually caused by high input voltage, high working temperatures and longer hours of continuous operation. Back of the board shows no damages or burns. While on the front we have a burnt fuse, a damaged MOSFET, one overheated resistance, another overheated resistance, Let's start testing from the bridge rectifier. It is used to convert AC current into DC current. Positive, negative and AC supply pins are labeled as can be seen. To test, set the multimeter on diode mode and put the black probe of the meter on the positive of the bridge rectifier and put the red probe of the meter on the AC pins of the bridge rectifier 1 by. It should read a voltage drop of 0.4 to 0.7 and there should be no continuity or buzzer sound. The second step is to put the red probe of the meter on negative of the bridge rectifier and black probe on the AC pins of the rectifier. It should show the voltage drop of 0.4 to 0.7 with no continuity. As can be seen, this bridge rectifier is shorted because it has continuity. Next we will test all MOSFET on the board. Put the black probe on the drain terminal and red probe on the source terminal. It should show voltage drop of 0.4 to 0.6 and should not have continuity or buzzer sound. Also, it should not read anything between gate and drain terminal. As seen, both of the MOSFETs are faulty here. Next we will test all the diodes on the board. The gray marked side on the diode represents the negative or cathode and other end is positive or anode. Put the black probe on cathode and red on anode. It should read a voltage drop of 0.4 to 0.6 and should have no continuity and buzzer sound. Next we will test all the resistors on the board. To test the resistor, set the multimeter on resistance mode and put any of the probes on the two ends of the resistors. You can use the shown table to calculate the value of the resistor using the color code. If the measured resistance are same as per the color code calculation, then it's a good resistor. Also, a resistor should not show any continuity or buzzer sound. Next we will check optocouplers. Put the red probe on the dotted terminal on the optocoupler and black probe on the other side terminal. All should read a voltage drop of 1 or above. To test a 4-pin optocoupler, put the red probe of the dotted terminal and black probe on the next terminal. It should show a voltage drop of 1 and above with no continuity and buzzer sound. Next we are going to test the through-hole type transformer. Please note, mostly to test these types of transformer, it is recommended to remove the transformer from the board and then test it so it won't mix the resistance and show continuity because of the PCB circuits or other components installed in line with the transformer. As seen, we tried to test it while it's installed on the board and it's showing continuity between all terminals of the primary and secondary side, which indicated it has a shorted coil. Let's remove it from the board and test. Set the multimeter on continuity or buzzer mode and check the continuity of the transformer primary and secondary coil. The primary side should have 2 separate coil and secondary coil should have 1 coil. As per the results, it's a good transformer. This is an inductor coil. It should show very low resistance and continuity. Let's check the other 2 transformer on the board using the same method we just used for the previous transformer. As seen, we are getting a mixed reading values on the primary and secondary coils of the 2 transformer. To confirm the functionality, we need to remove the transformer for the board and test. As per the results, it's a good transformer. Let's test the second transformer as well. As per the results, it's a good transformer. Next, we are going to test all Schottky barrier rectifiers on the board. To test a Schottky barrier rectifier, put the black probe on the cathode terminal and red probe on the 2 anode terminals, one by one. It should show the voltage drop of 0.2 to 0.5 and should not show any continuity or buzzer sound. Next we will test all the capacitors on the board. To test the capacitors, set the multimeter on continuity or buzzer mode and read the resistance of the capacitor. Any resistance with no buzzer sound means capacitor is good. Sometimes you may get a buzzer sound, but it could be due to circuit board or other components on the board. The best way to confirm is it remove the capacitor from the board and test it. As seen, one of the capacitor is giving buzzer sound. Let's remove it to confirm its functionality. After removing it from the board capacitor test, the results shows it's a good capacitor. The buzzer sound was due to other components on the board connected to this capacitor. Next step is to test all the ceramic capacitors on the board. Ceramic capacitor should show continuity with a low resistance value. A thyristor should show no continuity or resistance. Now we have tested all the components on the front of the board. Let's move to test the SMD components on the back of the board. Set the multimeter on resistance or buzzer mode and read the SMD resistance. It should show only the resistance value as mentioned on the SMD resistor. To test a Zener diode, set the meter on diode mode and put the black probe on the black marked side and red probe on the other side. It shall show a voltage drop of 0.4 to 0.6 and no buzzer sound. Next we test dual Schottky diode. Put the black probe on the cathode and red probe on the two anode one by one. It should show a voltage drop of 0.2 to 0.6 and no buzzer sound. Reverse the polarity and it should show no reading. Lastly, let's remove the ceramic capacitor and test its functionality. Set the multimeter on capacitance mode and read the value of the capacitor. It should be same as mentioned on the capacitor body. Thanks for watching. Please do subscribe us at UA Technical Solutions. Let us know in the comment section the topics of your choice to make this channel more relevant to you.